This video is only for those who plan on retaking the quiz in a couple days. So I'm just going to go over some of the tougher problems because there's really not a chance for us to go over the quiz together, and you don't have a copy of it for yourself. So here we go. All the formulas are up top. If I want to look at this one here says the first term is 5, and the next term is the previous term times 3. So it starts with the first term of 5. Just keep multiplying times 3, times 3, times 3 over and over again. Once you figure that out, that it's geometric, you can use one of the formulas that has g's in it, and write the formula. This one right here would be your first term times the multiplier power n minus 1. First term is 5 times 3 power n minus 1. Want the 14th term, all you got to do is plug in 14. The next one, what's tricky about number 2 is it's not exactly in the perfect form that we like. We've liked it in this form right here. We have the first term plus the difference times n minus 1. I took the difference and just distributed it, so it's not exactly in the perfect form that we like, but we can still figure it out. Want the first term, plug a 1. Want the second term, plug a 2. Third term, plug a 3, and so on and so forth. If you want, I don't remember if this question was actually on it, but if you want 427, want to know what term number that is, set it equal to 427, and then solve for n. You get 143. One of the harder problems here, or getting into the tougher ones, was about a runner who increased the running distance 5%. The first thing that I did is I started to write out the sequence. The first term is 5. To increase by 5%, you're going to multiply by 1.05. So times 1.05 makes 5.25, and then keep that pattern going, times 1.05 times 1.05. Multiplying by 1.05, that makes a geometric sequence, so we're going to use our geometric formula. Right here, your first term, here's your multiplier. It says for your first 20 weeks, so there's going to be 20 terms, and you get 165.3. Next one was about borrowing some money. So you write this out. Hopefully we can quickly see that this is a pattern here of adding, looks like 8. So add plus 8 plus 8 plus 8. I'm not asking for the sum of all that money. I'm just asking you how long it took to pay off. So I want to know what term number that is. Because it's not the sum, I'm not going to use my sum formula, this one up here. I am just going to use my regular explicit formula for arithmetic sequences. So put in 183, that's the last term. Your first term is 15. Adding 8 is the difference. Solve for n, and you should get 22. Similar idea down here. How many terms are in this sequence? This one here is geometric. So there's a multiplier from one term to the next. If you wanted to solve this, you would take this last term. Here's your first term, 0.625. Your multiplier is 2 power n minus 1. Solve this. It does require a logarithm, but you guys can do that. On the back, I'll just do a couple of these diverges and converges. The biggest power is on the bottom. That's 0 every time. Yes, this is a fraction, but 6/5 is actually going to be 1.2. 1.2 is bigger than 1, so when you're multiplying by 1.2 over and over again, it keeps increasing. Slightly tricky here for number 9. The best way to rewrite it is 4n minus 3, and on bottom, put the n's first of negative 5n plus 2. Since it's what we call a tie, there's a power 1 on top and bottom. All you have to do is circle the coefficients and get negative 4/5. Biggest power on bottom converges to 0. Adding, that's arithmetic, meaning it's going to continuously increase a little bit until it gets to infinity. It means it diverges. Last one, this means we're multiplying by 3/5. 3/5 is 0.6, so it keeps getting small, 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 and it approaches 0. We did okay with those. Ones that seemed to get the most of us were these probability ones. Probability here, you're playing this game, and you're going to play 8 times. The probability you win is 50%. I don't think that was actually on the quiz, but it can be assumed, and some of us struggle a little bit with that, but we'll talk about this now. What's the probability you win exactly 5 times? Well, first of all, we have to figure out how many different things can happen. Well, if I am playing this game, the first time I play it, there's 2 things that can happen. You either win or you lose. Okay, no ties. Second time you play it, you either win or you lose. Third time, and we're going to continue to play this over and over and over again, and I think it says we're going to play it 8 times. So the number of things that can happen is 2 power 8, which is equal to 256. That's the denominator of your fraction. Now, if we want to figure out the numerator, it says that we win exactly 5 times. Now, it doesn't say that we have to win the first 5 times we play. It doesn't say we have to win any specific, so that's going to be 8, choose 5 for your numerator. Okay? So your denominator is 256. 8, choose 5 is your numerator, which is going to be 56. So 56 out of 256, which is 7 over 32. Another way that you could do it is with Pascal's triangle. If we wrote out Pascal's triangle down to row 8, row 8 is right here. Because we're playing 8 times, we're going to look at row 8. So here, this is the number of ways you can win 0 times, number of ways you can win 1 time. So these are all your combinations. So if I want to win exactly 5 times, here's 0, 1, 2, 3, 4, 5. There we have 56 for the numerator. The denominator is the sum of all of these. These are all the different things that can happen when you play 8 times. If you added all those up, you would get 256. So it's the exact, make sure I got that right. Yeah, it's the exact same numbers, just finding it a different way. If you want to do it at least, well, that can be a little bit trickier with, I like Pascal's triangle the best, because here's the probability you win 0, 1, 2, 3, 4, 5 times, at least 5 times would be the sum of all of these numbers put together. Add those up for 93. You're still out of 256 different things that can happen, so you have 93 out of 256 for your probability that you win. Right here, this is the binomial theorem. It takes a bit to get into. If you want, email me if you have questions about it. Otherwise, this video is going to get super long. The infinite sum, I wrote out a few terms because it was kind of tricky. Plug a 1 to get the first term, plug a 2 to get the second term, plug a 3. Now I can see that the pattern is cutting in half. Your first term is 6. Plug it into the formula with 6 on top and 1/2 for your ratio, and you've got it. Email me if you have more questions, but we're going to requiz in a couple days.